Welcome to this BBB Industries segment on meters and test equipment.
Yeah, everybody needs to know how to use these meters and all the test equipment to work on today's cars. So let's get started. You know, diagnosing these cars is going to take 50% of the time. Half the time you're going to spend in the bookwork, looking at schematics to figure out what's wrong with them. And you have to use this test equipment and be confident with it in order to fix them right the first time. Things like these VAT40s and, of course, this voltmeter.
And the DVOM is not the only meter we're going to teach you about. We're going to teach you about this test equipment, this VAT40, this VAT45, the 3750, and this handheld tester.
Yeah, we'll even look at some meters that perhaps you shouldn't be using. Something like this little one here. This is only capable of about 100 amps. Start loading batteries up to 250, 300 amps. Not a good idea. And then you have this analog voltmeter. This is low impedance. Low impedance meters, a little dangerous for computer circuits.
I got a feeling there won't be any test lights in this video.
No test lights here. Manufacturers put this equipment in to meet OEM specifications. This is good stuff. It deserves proper testing.
We're going to be going over amps, volts, and resistance. And if you need a refresher, look at our fundamentals video.
Yeah, there's a lot here, so buckle up. Let's get started. Now this one's for volts and ohms. Let's start out with AC voltage.
I got my spark tester here. I went ahead and set my meter to alternating volts. And now I got my leads here. And what I'm going to do is unplug my crank sensor here and go across it with these two leads. And then I'm going to turn my spark tester on, and I'm going to start generating a voltage.
And there it is. What you're actually generating is an AC voltage. That's an alternating current. That's a magnetic pickup, a permanent magnet. It's using a magnetic field to induce a voltage into that sensor in order to make a voltage. Wheel speed sensors, vehicle speed sensors, crank, cam, a lot of them use that. And we'll cover that in detail in the magnetism series. Let's switch over to DC volts. Now DC volts, car uses DC volts all over, direct current. That's basically what a battery produces and everything uses. We always measure volts in parallel. So what he's going to do, he can do two different measurements. He can simply come across the battery, and what he's measuring there is a voltage drop or potential difference from the positive to the negative, and he's showing his voltage right there at 13.51. That's what the battery is capable of producing. That's a voltage drop from the positive to the negative cable. Now we can also do voltage at a point. He can come right here and go to this starter lead, and what he has is same thing, 13.57 or 51. We can take that mathematically, find out our voltage drops or whatever's going on with the circuit and diagnose it. Now, our last style is millivolts. Millivolts is anything under a volt. Now, we start dealing with some knock sensors. These are little piezoelectric generators that sense vibrations in the coolant. They generate less than a volt. And then, of course, your oxygen sensor. Now, your oxygen sensor, anywhere from 100 millivolts to 900 millivolts, fluctuating. It's a sine wave, but it's still a DC voltage.
I went ahead and switched my dial over to ohms, a Greek sign for omega, resistance.
Now resistance is in everything. Resistance is opposition to current flow. Opposition to current flow. Any windings of wires, we have an ECT. This is an engine coolant temperature sensor. And what he is, he's a thermistor. He's a variable resistor, but a resistor nevertheless. So if you go across those two terminals, from one side to the other, we're making a reading. We're making continuity and a resistance value. Now this resistance will change with temperature, if it's a negative coefficient or a positive coefficient. This injector, a little bit different. We're just going in with the wire windings and we're using magnetic induction, once again, magnetism, to pick up that solenoid and put him down to open and close that injector. Now you can read those windings. That will actually have a specification. You can look it up in your service manual and it'll tell you if you have a good or bad injector. Door lock, same thing, solenoids, open and close. Now resistance is good, but I want to show you a little demonstration here that sometimes I don't like resistance when we start using heavy amp circuits, starters, you start drawing massive amount of amperage, and I'll show you why. We got two battery cables here. Now this one is a brand new, nice brand new battery cable, everything's intact. We skinned the wires back, and Chase is hooking up ohms of resistance. How much do we have there?
We got about 0.1.
All right, now if we go this one here, we skinned him all the way down. We only left a couple of strands. If we measure him, We have about the same thing.
About the
Yeah,
same.
about
yeah.
the same, all right? The point is that you're going to have the same resistance values. This may be 1, this may be 3. That's not enough ohms of resistance, in my mind, to tell me there's nothing wrong with the cable. But if you try to pump some amps through here, starting motors are drawing 300 amps. You put 300 amps through here, this is nothing more than a fusible link. It's going to burn. Now, these starters are designed to operate on a specific amount of amperage. You've got electrocounter EMF coming back. These things are designed to operate properly. So voltage drop is the way to go. You can just switch your meter back to volts. And in DC volts, if he went across that wire, what he would find if we put pressure into it, we don't have any pressure here, but if he put pressure and we started running some electrons through, you're going to have a massive voltage drop right there, and this guy would have relatively none.
Next on the dial, we got continuity and diode test.
Continuity is nothing more than checking a wire, maybe from the front of the car to the back of the car. You go across that wire, meter beeps, you got continuity. Now, a